Hi guys, welcome back. In this video we are going to see what are smart contract libraries and how we can write a library. So basically if you are a programmer and if you have done programming in different programming languages, you must know what libraries are. These are some codes, some reusable codes which you have written or which you have imported from some library, and you are using it in your own main implementation. So basically once we write the libraries, we can reuse them. So basically it's the same. A library in Solidity is a different type of smart contract that contains reusable code, and once it is deployed on the blockchain, we can use it as many time as we want. And it's an add-on. For example, if you see this open ziplins is ECDSA library, you see that it allows you to recover the signature to check if the signature is valid or not. So once this library is written, we can use this code in our main implementation as much time as we want. So that's what libraries are. Like, to understand more, let's start coding. I would So we can create this code in remix id. So let's create a file, string utils dot sol, and we can start with spdx license identifier mit. So basically we first need to define the Solidity version. Then in order to define a library, you write the library keyword, string utils. We must keep in mind that we cannot inherit from library. We cannot say it's ERC20 or something like this, because it's a standalone program, and it defines some functions which are view or pure, and then you can inherit these functions in your main smart contract implementation. So we are just in this string utils library, we are going to define three function: concatenate. I forgot the spelling of concatenate the strings. For example, if there is a string a is equals to my, and string b is equals to name, so the concatenated string will be my name. So these are two strings and we are just adding them, and then we are going to write a function of check if string is empty, and then we are going to write a function compare the strings if they are same or not. So let's start writing this function concat string memory a and string memory b. The function is internal pure returns string memory. So we are taking two input strings and we are returning a string. Instead of directly performing the computations on string, we are first going to convert it into bytes, because it's easy to handle bytes in Solidity. So we are going to say it's bytes of a, and we are going to convert it into bytes, and then we are going to say bytes memory bytes b is equals to bytes of b, and then we are going to define a new bytes which is going to store the result. And what is the length of these results is new bytes a dot length plus bytes b dot length. So we are going to convert them into bytes, and then we are going to define a new bytes result, which is actually the total length of this result is the length of a plus length of b, and then we are going to define k is equals to 0, because it's like this. So result of k. So first of all, we are going to feed k as this, as all the bytes of a, and then we are going to feed k as all the bytes of b. So let's write the function for, we are going to loop through all the bytes, characters in these bytes, and u int 256 I is equals to 0, I is less than bytes a dot length and I plus plus, and we are going to say result of k plus plus is equals to bytes of a or I. So what we are doing here is, what's the problem? Expected this. Okay. So what we are doing here is, and what's the problem here? Okay, we are going to return. So we are getting all these i's in this bytes of a, and we are assigning it to the result. And similarly we are going to do unsigned int 256 I is equals to 0, I is less than bytes b dot length I plus plus, and we are going to do the same thing. Result of k plus plus is equals to bytes b of I. So once this loop is done, we might have some, what is the value of k? It's bytes of a dot length. So the k value will be the length of this bytes, and it's going to start from this bytes dot length and it will go to bytes b dot length. So we are, and then we are just going to return, we are going to convert these bytes into string, and then we are going to return string because it's string memory. So this function is ready. Let's write the function is empty and it's string memory underscore str, and the function is again internal pure returns. It's going to return bool, either it's the string is empty or not. We can again convert it into bytes of str, and then we are going to return bytes str dot length is equals to 0. So if, did you mean underscore str? Yeah, we mean underscore str. Thank you. So we are going to convert it into bytes, and then we are going to see if the length is 0, it returns true, otherwise it returns false. And finally, if we go to function compare string memory a string memory b internal pure returns, it's going to return bool 2 because we are comparing either they are same or not. So we are going to return, we are using KECCAK catch 256, this is the hash, and then we are going to say bytes of a is equals to catch 256 bytes of b. So we are first converting it into bytes, and then we are calculating the hash. If the hashes are same, it means the strings are same, otherwise the strings are not same. So we have implemented this library. So let's create a new file, test contract dot sol, and I'm going to copy the same thing here, and first of all we need to import this library string utils dot sol, and then we are going to define test contract. Okay, so here is the main part. When you are using the libraries, you need to use this keyword using the name of library string utils for string. Because we have defined this library for strings, we are saying for all the strings which are defined in this contract, we are using string utils for those strings. And then we are going to write, let's say, test concat. We are going to pass string memory A, string memory B, public pure returns what it's going to return, string memory. So basically we are importing this concat function here, and what we are doing, return a dot concat b. So when we are calling this a dot concat b, it's going to go here in the concat function. Where is the concat? Here is the concat function, and it's going to do all these things, and then it's going to return the result. It's that simple. Then we are going to test is empty, string memory str, public pure returns bool, and then it's going to return str dot is empty. It's that simple. So you are going to use this dot operator in order to call these functions. So when we are going to say dot is empty, it's going to take the string which is here, and it's going to do all the stuff which we have defined here, and then it's going to return either it's a string or not. And finally we are going to write test compare string memory A, string memory B, public pure returns bool, and it's going to return a dot compare b. So when you are using libraries, you need to define your functions like this, and then if you are inputting two variables like a and b, you need to write a dot compare b. So compare a with b, string dot is empty, and concatenate a with b. So let's go and deploy this smart contract. Since we are importing it, so we don't need to deploy the string utils because we are importing this contract in here. So if we go to this contract, test compare, so we are going to compare two string, let's say asdf and asdf. Compare, it must return true, it's true. So let's remove this f, or let's put equal sign, it returns false. And let's test concat my name and is Danish, and it must return my name is Danish in a single string. So you see, if my name is Danish, let's try to remove this space, test concat. So you see there is no space, so you must give the space here, and it's going to see my name. And then test is empty. Let's put the empty string first, it's returned true, it returns true, and then put something, it returns false. So basically the libraries, they are the reusable codes or functions which we can write, and then we can import it in our smart contract, or we can also give the address of this library contract, and we can call these functions in order to reuse the code which we have already written in this library. So that was all about libraries. So thank you for watching, take care, bye bye.